that research in India, we actually have a huge population. In that context, we have huge number of people with various conditions. It can be infectious diseases, it can be chronic diseases, it can be almost anything. We have lots of people and lots of issues that are related to our population. What is good for the West not necessarily is going to apply to us. Our genetic architecture is different. The kind of mutations you find in the genes will be different. So if we don't understand our population and our population genetic diversity, whether it is with respect to heart disease or the tuberculosis infections or for that matter anything else, we would not be able to treat our own people as effectively just based on the literature that is available from the West. That's the bottom line, and that's the way it is. So how can we change it? As Dr. Gopichandra has clearly mentioned, one of them starts very early in our life. Inculcating this when we are young students, providing them the relatively proper exposure and making them understand that curiosity is a good thing, not a bad thing. Not everything has to be kind of memorized the way we are told, memorize and go and puke it in the exams. That per se is counterintuitive to really what we call as research, because research is delving into something unknown. So memory lately, that kind of a thing has to change more towards inquisitiveness, trying to figure out things and ask questions, which is not very much encouraged in our schools and at a later point of time in colleges. It's only when I got into PhD program at IISc, the first concept of start questioning or trying to figure out something unknown without trying to get the result. Even in colleges, when you go, you are already told what the result should be and you work towards it. Right? I did in chemistry, physics, mathematics. But that's not what it is supposed to be. Research is about trying to report what it is like, not creating what you want. Right? So that is one thing, aptitude. Second thing is obviously, as the time progressed, when I was a student, there were 4 institutes worth talking about for doing PhD. One of them is created by great Ratan Tata's predecessor and Jamshedji Tataji, the Heads of Sciences, where I had the opportunity and the privilege of doing my PhD. And other one is also created by Tata, that is Tata Institute of Fundamental Research, and Ccmb and NII. These are the 4 places people used to talk about in those days. And that's it. Really, now if you look into, if you're a young student looking for a PhD opportunities, there are many places. ICERs have come, IITs are doing research, and there are so many other institutes, so many universities which are doing original quality research. So I can see the productivity as I see compared to then to now has grown, has really gone up. And there's a lot of money that has been poured into it. And that is seen and the results are seen. And now the other thing that I see is a strong collaboration between clinical researchers, clinicians, and the academicians. For example, we have a program where we work with kids. So that we are trying to figure out various things. We have scientists in Ccmb who are working on coronary heart disease, and there are people who are working on reproduction in terms of why do you have implantation failures. And they are using mice as the model system. Whereas implantation failures is something that happens in humans, right? And so if we really can figure that out, use the knowledge that we generate from the research towards why something fails in the clinical setting, it would be great. So these things require obviously high-end machines and high-end techniques. One of them, like you may know and you are fully aware, omics has really become the buzzword. What is omics? Genomics, proteomics, metabolomics, you name it. They're all essentially trying to figure out and microbiome. All these are the buzzwords playing here. People were not really aware of most of them till COVID came along. And now everybody talks about RT-PCR and sequencing more routinely than what they used to earlier. So in that context, I would say there is a certain, I know it's a bad news, a lot of people unfortunately passed away during COVID, but it has changed the way Indian academia, clinicians and industry collaborated with each other. And that was most probably the first time I saw the change happening. And when I came here, I saw that in much closer quarters because Ccmb was heavily involved in COVID work. But it is with that foundation, now we are capable of sequencing the human genome for approximately 70,000-80,000 rupees. Your whole genome can be sequenced. Your whole, whatever the microbial population that is there in your body can be identified. Not very expensive. Expensive is a very good term. You have to understand that first time human genome was sequenced, it took 9 years and billions of dollars. Now we are talking about 70,000 rupees, which is essentially $1,000, roughly. And that's what you can get your genome sequenced, right? And bacteria like tuberculosis and other things